This video is going to define the derivative. In an algebra class, you probably talked about the idea of slope, the fact that slope is change in y over change in x. And you might have also found average rate of change. And the average rate of change of a function, so in red, if this is the graph of f of x, the average rate of change would be the slope of a line that connects 2 points on the graph of that function. If we say that the first point is a comma f of a, and the second point is h units over, that would be a plus h, comma f of a plus h, then my slope formula becomes change in y, f of a plus h minus f of a, divided by change in x, a plus h minus a. We can cancel those a's out, and this simplifies down to f of a plus h minus f of a divided by h. This is an expression that will give us the slope of a line that connects 2 points that go through a function. This is known as a secant line, a line that connects 2 points on the graph of the function. And this quantity is also the average rate of change of that function. Now, if we take these 2 points and we make them closer together, that means we are making h smaller, and we make them even closer together. Well, we can think about what happens as h gets really, really small, and what happens as h goes to 0. Well, if we let h go to 0, this line is now going to become a tangent line, and the slope of this tangent line will give us our instantaneous rate of change. So mathematically, that means if I want to find the slope of the tangent line, or my instantaneous rate of change, I can take my average rate of change formula, f of a plus h minus f of a divided by h, and I'm going to take the limit of that as h goes to 0. And this is the limit definition of our slope of the tangent line. Let's do an example. For the function f of x equals negative x squared plus 4x, let's find the slope of the secant line that passes through x equal 1 and x equal 4, and then we'll find the slope of the tangent line at x equal 1. To find the slope of the secant line, we really just need to take change in y over change in x. In this case, that means we're going to find f of 4 minus f of 1 divided by 4 minus 1. We're just computing slope. F of 4, if I plug 4 into my function, I get negative 4 squared plus 4 times 4. That is going to be 0. F of 1, negative 1 squared plus 4 times 1 should be 3. So plugging that in, f of 4, so 0 minus f of 1, which is 3, divided by 4 minus 1, that's negative 3 over 3, or negative 1. So the slope of my secant line, or the slope of a line that passes through the graph of f of x equal negative x squared plus 4x, and passes through x equal 1 and x equal 4, has the slope of negative 1. Now if I want to find the slope of the tangent line, I'm going to have to use this limit definition. I'm going to take f of a plus h minus f of a, that's my change in y, divided by h, that's my change in x, and I'm going to let h go to 0. In this case, the a, the number we're interested in, is 1. So we're going to take the limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. So I'll start by finding f of 1 plus h by plugging 1 plus h in for both of the x's in my function. So we get negative 1 plus h squared plus 4 times 1 plus h. 1 plus h squared, I'm going to have to FOIL that out. That's going to give me 1. And then my inner plus my outers is 2h plus h squared. And I distributed the 4 to the 1 plus h. That gave me 4 plus 4h. Finally, I distribute the negative to my 1 plus h squared. That gives me negative 1 minus 2h minus h squared. And I still have the plus 4 plus 4h. If I combine like terms, minus 1 plus 4 is 3. And then minus 2h plus 4h is 2h. And we have a minus h squared. So this is my f of 1 plus h. I can find f of 1. I actually already did that by just plugging 1 into the function, and I got 3. And now I'm going to take my f of 1 plus h and my f of 1 and plug those into my limit definition. So f of 1 plus h was 3 plus 2h minus h squared, and then minus f of 1, which was 3, all over h, and we'll take the limit as h goes to 0. Those 3's are going to cancel out, and I'm left with 2h minus h squared divided by h. Now, if I tried to find the limit right now by plugging the h in, I would end up getting 0 over 0, which is indeterminate. So we are going to have to simplify this even further. And we can do that by factoring an h out of that numerator. So I can factor an h out of the 2h minus h squared, and I'm left with 2 minus h. And then we can cancel those h's out, and we're left with limit as h goes to 0 of 2 minus h. Finally, I plug in 0 for h, and I'm left with 2. So the slope of my tangent line here is 2. And I have a picture of the problem that we just solved. In red is my function f of x equals negative x squared plus 4x. So that's our function. In blue is my secant line. It goes through the point 1, 3 and 4, 0. And this line has a slope of negative 1, down 1 over 1. And then in green, I graphed my tangent line. My tangent line at the point 1, 3 has a slope of 2, up 2 over 1. And so those are the two values that we just computed in this problem. Now the slope of the tangent line also represents the instantaneous rate of change. And this is a really important quantity, and so we're going to give it a special name and call it the derivative of our function. So the derivative of our function is the same thing as the slope of the tangent line and the instantaneous rate of change. We are going to use this notation f prime of a. So it's like a little, apostrophe. We'll call it a prime. F prime of a is a notation that means the derivative of f at x equal a, or the slope of the tangent line at x equal a. So let's use the limit definition of the derivative to find f prime of 3 for the function f of x equals the square root of 7 minus x. Then we'll write the equation of the line tangent to f at x equal 3. So f prime of 3 is asking me for the slope of the tangent line. So I'm going to use my limit definition, and I'm going to find the limit as h goes to 0 of f of 3 plus h minus f of 3 divided by h. The 3 is my a value. So to get started, we have to find f of 3 plus h. I'm going to take 3 plus h, plug that in for x in my function. That gives me square root of 7 minus the quantity 3 plus h. I can distribute that negative, combine like terms, and I'm left with square root of 4 minus h. Then I'm going to find f of 3. Square root of 7 minus 3 is root 4, or 2. Plugging these values into my limit definition, so f of 3 plus h got plugged in, and then I plugged in my f of 3, and so now I have limit as h goes to 0 of square root of 4 minus h minus 2 all over h. Now, if I plug in h equals 0, I end up getting that indeterminate 0 over 0. So once again, I'm going to have some more work to do. And this problem has a square root, so we can use the same strategy we learned when we first talked about limits. We're going to try to rationalize the numerator by multiplying by the conjugate. So I have square root of 4 minus h minus 2 in my numerator. So I'm going to change that minus sign, the one between the square root and the 2, I'm going to change that to a plus sign, and that is called my conjugate. So we're going to multiply by square root of 4 minus h plus 2. And we're going to have to do that to the top and the bottom so that we're, in a sense, multiplying by 1 and not actually changing the value of this expression. All right, we multiply by the conjugate because that allows us to use our difference of squares formula. We have something of the form a plus b, a minus b, where a is my square root 4 minus h, and b is 2. When we multiply those things together, we should get a squared minus b squared, or root 4 minus h squared minus 2 squared. That's going to give me, when you square a square root, you get 4 minus h, just gets rid of the square root, minus 2 squared, which is 4. So my numerator is 4 minus h minus 4. And then in the denominator, I'm just going to copy down what we have. We've got h times that conjugate, square root of 4 minus h plus 2. I can combine like terms in the numerator. The 4's go away, and I'm left with negative h over h times square root of 4 minus h plus 2. Finally, we've got a common factor. Those h's cancel out, and we're left with negative 1 over 4 plus h plus 2. And this is something that we can find the limit of as h goes to 0 by just plugging 0 in for h. That gives me negative 1 divided by square root of 4 plus 2, or 2 plus 2, or 4. So the slope of my tangent line is negative 1/4. Now this problem is also asking us to write the equation of our tangent line at x equals 3. And we just found our derivative. The derivative, negative 1/4, is the slope of that tangent line. So we've already found the slope of our tangent line. And you might remember from algebra class that you can write the equation of a line using the point slope formula I have on the screen. That is, y minus y1 equals m times x minus x1. So if you know the slope, which we do, that's our m, and we know a point on the line, we can get the equation of the line. And so in this case, we can use the point x equals 3, since that's our point of tangency. So my x1 is going to be 3. And I'm going to find my y1, the y value of that point, by just plugging 3 into my function. F of 3, we did this computation before, but we could do it again, is going to be square root of 4, or 2. And so plugging those values in, I get y minus 2 equals my slope, negative 1/4, times x minus 3. And that is my equation of the tangent line. It's in point slope form. It's perfectly fine for you to leave equations in this form. I think point slope form is a really nice form to write equations in. Finally, I created a picture of what we've just done here. So in red, that is our function square root of 7 minus x. And then our point of tangency is right here, 3, 2. And then in purple, I just graphed that tangent line that we found. And we can see that that line is just touching the graph at the point 3, 2 at my point of tangency. And it's actually really close to the graph of the function near that point of tangency. I want to show you one more example of using the limit definition to find a derivative. Let's find f prime of negative 2 for the function f of x equals 5 divided by x minus 1. Using my limit definition, f prime of negative 2 is going to be the limit as h goes to 0 of f of negative 2 plus h minus f of negative 2 all over h. Again, I plugged in negative 2 for the a. F of negative 2 plus h means I'm going to replace the x with negative 2 plus h. So that gives me 5 over negative 2 plus h minus 1, combine like terms, 5 over negative 3 plus h. Then I'm going to find f of negative 2, plugging negative 2 in for x, that gives me 5 over negative 3, or negative 5/3. Those two values are going to go into my limit definition. So f of negative 2 plus h, 5 over negative 3 plus h, minus f of negative 2, which is negative 5/3, all over h. Minus a minus becomes a plus. And then I'm going to simplify this expression. If I were to plug in the h equals 0 right now, I would get 0 over 0, my indeterminate form. So to simplify this expression, I'm going to multiply everything by the least common denominator. I have a denominator of negative 3 plus h, another one of 3, and then the bottom is technically h over 1, so denominator of 1. That means my LCD is going to be 3 times negative 3 plus h. So I'm going to multiply everything on the top and the bottom by that LCD, making sure I'm doing the same thing to the top and bottom, so I'm technically multiplying by 1. In the numerator, I'm going to take it's 5, positive 5 over negative 3 plus h, and I'm going to multiply that by my LCD. The negative 3 plus h's are going to cancel out, and I'm just left with 5 times 3, or 15. Next term, now we're going to do 5/3 times that LCD, 3 negative 3 plus h. This time the 3's cancel out, and I'm left with 5 times negative 3 plus h. I'm just going to copy down the denominator. H times 3, I wrote that as 3h, and then times negative 3 plus h. Now we can distribute in the numerator. 5 times minus 3 is minus 15. 5 times h is 5h. Combine like terms. 15 minus 15 is 0. I'm just left with 5h. And then the denominator is still 3h, negative 3 plus h. Finally, those h's cancel out, and I've got 5 over 3 times negative 3 plus h. To finish, we can plug in 0 for h, and that gives me 5 over 3 times negative 3, or negative 5/9. So f prime of negative 2, or the slope of the tangent line at x equal negative 2, is negative 5/9. That was my last example. As always, let me know if anything is unclear.